Learning objectives. After studying this module, you will be able to know the meaning of the term correlation, understand the relationship between variables, compute the different measures of correlation, evaluate the degree and direction of the relationships. Correlation. Introduction and types of relationship. Introduction. Correlation is a device used to measure the relationship between two variables statistically. If a change in a variable results in a change in other variable, such variables are known as to be correlated. The existence of a correlation between two variables x and y basically implies that when the value of one variable is found to change in one direction, the value of the other variable also changes either in the same direction or in the opposite direction, but in a certain way. Types of relationship. There are two types of correlation, namely positive or direct correlation and negative or indirect correlation. A positive correlation is a relationship between two variables when increase or decreases in the value of one variable results in the corresponding increase and decrease in the value of others as well. The correlation between income and expenditure is direct, as the increase or decrease in income will directly impact the expenditure. Negative correlation. A negative correlation is a situation where an increase in the value of one variable results in a decrease in the value of the other or vice versa. The relationship between speed and distance is negative. As speed increases, the distance decreases or vice versa. Hence, we can say that when the change in variables takes place in same direction, it is called a direct or positive correlation. And when the change in the variable takes place in opposite direction, it is called negative or indirect correlation. Techniques for measuring correlation. 1. There are three different techniques of measuring the correlation between variables, and they are scatter diagrams, Karl-Pearson's coefficient of correlation, and Spearman's rank correlation. A scatter diagram represents the relationship between variables graphically. Karl-Pearson's coefficient of correlation gives a numerical measure of the linear relationship between two variables, while Spearman's coefficient of correlation measures the linear association between ranks assigned to individual items according to their attributes. Scatter diagram. The scatter diagram method is the easiest tool to study the correlation between two variables, in which the values for each pair of a variable is plotted on a graph in the form of dots to obtain as many points as the number of observations. It is a visual method of examining the relationship without calculating the numerical value. With the help of a scatter diagram, we can have a fair idea of the nature of the relationship. In a scatter diagram, the degree of the nearness of the scatter points and their direction enables us to study the relationship. If all the points lie on a same line, the correlation is perfect and is considered to be in unity. If the scatter points are widely dispersed around the line, the correlation is low. The correlation is said to be linear if the scatter points lie near a line or on a line. Techniques for measuring correlation 2. Karl-Pearson's coefficient of correlation. This method is also known as the product moment correlation coefficient, or simple correlation coefficient. It gives an accurate numerical value of the degree of a linear relationship between two variables. It is important to mention that Pearson's method should not only be used when the relationship between the variables is linear. In the case of a nonlinear relation between x and y, Carl Pearson's method of the coefficient of correlation can be confusing. Properties of correlation coefficient. Correlation coefficient between two variables x and y are denoted by Rxy. R is a pure number and has no unit. Units of measurement are not a part of R. The value of Rxy always lie between -1 and 1. If R lies outside this range, then there is some error in calculation. A negative value of R denotes a negative or inverse correlation. That is, a change in one variable leads to change in another variable in the opposite direction. A positive value of R signifies a positive or direct correlation, where a change in both the variables takes place in the same direction. The magnitude of R is unaffected by the change of origin and change of scale. If R is equal to 1, then the correlation is positive. If R is equal to -1, then the relationship is inverse. If R is equal to 0, then there is no correlation between the variables. A low value of R indicates a weak linear relation, but there may be a non-linear relation. Techniques for measuring correlation 3. Step deviation method to calculate correlation coefficient. When the values of the variable are large, the problem of calculation can be extensively reduced by means of using a property of R. It is that R is independent of change in origin and scale. This method is known as step deviation method. It involves the transformation of the variables x and y. Spearman's rank correlation. British psychologist C.E. Spearman developed the rank correlation method. Spearman's rank correlation coefficient can be used in situations where there is a relation whose direction is clear but non-linear. Extreme values don't affect the Spearman's correlation coefficient. This is why it is better than Carl Pearson's correlation coefficient. Hence, if the data contains some extreme value, Spearman's correlation coefficient can prove to be beneficial. Features of Spearman's correlation coefficient method. Rank correlation coefficient and a simple correlation coefficient have a similar interpretation. Its formula is derived from a simple correlation coefficient wherein individual values are being replaced by ranks. These ranks are used for the calculation of correlation. Like the Pearson's coefficient of correlation, it lies between 1 and -1, though generally it is not as precise as the regular method. This is due to the fact that it does not make use of all the statistics regarding the data. Calculation of rank correlation coefficient. To calculate the correlation coefficient using the rank method, we need to arrange the values in ranks. After arranging the values, find out the difference between the ranks, square them up, and sum the squared differences. Set up the premise to compute the correlation and conclude the data based on the findings. Summary. Let us summarize what we have learned in this module. Correlation studies the relationship between two variables. There are two types of correlation, positive and negative. When the change in one variable results in a corresponding change in the other in the same direction, the relationship is called positive or direct, and when the change in one variable results in a corresponding change in another variable in opposite direction, then the relation between them is termed as negative or indirect. Scatter diagrams give a pictorial presentation of the relationship between two variables. Carl Pearson's coefficient of correlation R measures numerically linear relationship between two variables. R lies between -1 and 1. Spearman's rank correlation can be used to compute the linear relationship numerically when the variables cannot be measured accurately. Relationship between the values of two variables have a constant ratio is said to be a linear relation, whereas the values of two variables don't have a constant ratio. Then the relationship is said to be nonlinear. The knowledge of correlation gives a fair idea of the direction and degree of change in a variable when the correlated variable changes. Repeated ranks need correction factors. Correlation does not mean causation, it only means covariation.